Hi everyone, welcome to the Earth Science Regions Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on the sun's path. Now if you look at the sun's path throughout the year, you'll notice that there's some alteration to the path, and that coincides directly with our seasons. So we know that our sun rises in the east and sets in the west, but the amount of energy that we get from the sun, the amount of incoming solar radiation that we get is going to alter based upon the season that we're going to be at. Now there are some factors that influence this. The angle of insolation. The angle of insolation in the morning and the evening is much lower than it is in the afternoon. So that's why it's cooler in the morning and evening and a little bit warmer in the afternoon. How long the sun's going to be out for? Well, in the summer here in New York, it's out for about 15 hours. In the wintertime, it's out for about 9 hours. The latitude that it strikes is going to be important. North Pole and South Pole are much colder than the equator. And the strength of insolation. The higher the angle, the greater the intensity. The lower the angle, the weaker the intensity. So you'll see that the North Pole and the South Pole have much lower angles and they have much weaker intensity from the sun. That's why it's quite cold. You'll see how wide that light beam is when it strikes the surface. Compared to the equator, where it's much more direct, that angle right there is about 90 degrees to the surface. It's much more compact, it's much more direct. That's why it's much warmer at the equator compared to the poles. So the sun's energy coming in, that's a much lower angle of insolation. You see how wide that light beam is? That leads to lower temperatures, lower angle, and lower intensity energy from the sun. Compare that with the equator, where it's much more direct, much more compact, higher angle, greater intensity, higher temperatures. Not only with latitudes does that change, but also through the course of the day. Okay, you can see in this case, my afternoon sun is pretty close to 90 degrees. Okay, that's going to be a very direct ray. It's going to probably give me some pretty hot temperatures through the course of the day. Now, either the sun rising or the sun setting, you'll see that the light beams coming in from the sun are significantly lower. Lower the angle, lower the intensity, lower the temperature. So your morning and evening are a little bit cooler than your afternoon, all because of the angle and the intensity of the sun. Now, you have a couple important dates here. You have the first day of summer, the first day of spring, the first day of fall, and the first day of winter. They all have specific names to them, so make sure you know the names of those important dates. Now those dates have certain latitudes that you need to associate with them. The reason is because you need to know where the sun is going to be at the zenith on those four basic dates. Zenith is going to be the point directly above you, giving you sun's energy at about a 90-degree angle. So on June 21st, the Tropic of Cancer is going to have this sun at the zenith. On March 21st and September 23rd, the equator is going to have the sun at the zenith. And then December 21st, the Tropic of Capricorn, the sun is going to be at the zenith there. So you have 4 dates, 3 latitudes, because your 2 equinoxes, okay, are going to double up with the equator. 4 dates, 3 latitudes you need to know. Now you see that the sun's path varies significantly between summer and winter. Summer, it's got a much higher angle of insolation, much more intense energy. It's out for a longer period of time, which gives you hotter temperatures. The winter is the exact opposite. Much lower angle gives you much lower intensity light, which gives you the colder temperatures. Now shadows are going to be important. They always tend to be asked on your Regents exams. You have to realize that the noon sun's always in the southern sky here in New York State, which means that your shadow is always going to point in the opposite direction. So whether or not the sun is in the east, if it's in the southern sky, or if it's setting in the west, realize that your shadow always points in the opposite direction of the sun. Your shadow length is going to vary as well. From sunrise to sunset, it's going to get smaller as it gets up to noontime, and it's going to get larger as it gets down to sunset. Now here's a classic diagram from the Regents that shows you your 4 basic dates. Remember, March 21st and September 23rd, they double up, of the sun's path. And what we're going to do is we're going to take this diagram and we're going to break it down season by season. You definitely need to have an idea about what this diagram actually means. So the first date's going to be your winter solstice. You'll notice that the sun is rising in the southeast. It's going to be setting in the southwest. It's only out for about 9 hours out of the day. Now when that sun rises up, your shadow is going to be pointing in the opposite direction of the sun. That sun's going to get to a maximum altitude of about 24.5 degrees above the horizon. You'll notice that the shadow length just got smaller. And you'll notice that my noontime sun, the shadow is pointing in a northerly direction. As that sun sets in the southwest, the shadow always points in the opposite direction and gradually gets longer as well because of the lower angle of insolation. So regardless of the season, your wintertime sun is going to be out for the shortest period of time and has the lowest angle of insolation because it has the lowest altitude, only about 24.5 degrees above the horizon. So when you take a look here at the shadow, and you also take notice that your observer here is looking at the sun in the southern sky, your shadow is going to be pointing north. Now, just take note of the length of the shadow at noontime in winter, and we're going to try to compare that, try to remember that, what the shadow looks like when we get to the summertime. Now, my sun is going to rise in the southeast part of the sky, and that's going to be where my wintertime sun is going to rise. It's only going to be out for about 9 hours out of the day. Then I get to fall and spring, which are my autumnal and vernal equinox. You'll see that my sun is going to be rising exactly east and setting exactly west. My altitude is at a 48-degree angle now. You'll notice that my shadow is going to get smaller as it gets noontime, so take note of the shadow length and the shadow direction, and then also when it sets. Now my sun is going to be out for 12 hours on this day across the entire planet. Now that person, again, for fall and spring, needs to look in a southerly direction. Notice that my noon shadow is a little bit smaller than what it was in wintertime because my angle of insolation is a little bit greater now. Again, my sun's going to rise exactly east and set exactly west for fall and spring. Now, summertime. It's going to be my summer solstice. Now, you'll notice that my noon sun will not hit the zenith, will not be directly above the observer, but it's going to rise in the northeast. It's going to take a very long path, 15-hour path now, across the sky. My shadow's pointing opposite. Now watch what happens to my shadow length. Significantly smaller. So even though at noontime, for every day of the year, your smallest shadow is going to be at noontime, if you compared your 4 seasons, summertime would be the shortest, wintertime would be the longest, because your sun's altitude now is 71.5 degrees above the horizon. Much more direct sun, higher angle of insolation, greater intensity here. It's going to set in the northwest. Notice the shadow gets longer at sunset, and it points in the opposite direction of the sun. Again, that noon sun during summertime is going to be in the southern sky, a really small shadow pointing north at noontime, and again, you have a much, much higher angle of insolation here. Again, now my sun's going to rise in the northeast part of the sky during the summertime here in New York State. Well, you also have a couple other latitudes that you need to know. Well, this is significant because at 23.5 degrees north, this is going to be June 21st, the sun's going to be at the zenith. You'll notice that that noontime sun is going to be directly above the observer. That's going to be a picture that would be indicative of the Tropic of Cancer, and the sun is going to be at the zenith on that specific date. You'll notice that this is the Tropic of Capricorn. You'll notice now that the sun is rising in the southeast and setting in the southwest. Everything's a little bit opposite in the southern hemisphere, but you'll notice this is going to be the latitude that gets the most direct sun on December 21st. The sun is at the zenith. The reason for that? It's the southern hemisphere's summertime on this date. Even though it's our first day of winter, it's going to be southern hemisphere's first day of summer. This is going to be what the equator looks like. This is going to be on March 21st and September 23rd. The sun's going to rise exactly east and set exactly west. And the sun's going to be at the zenith on those 2 dates at the equator. Then finally, this is going to be the North Pole on March 21st and June 21st. You'll notice that there's 2 paths of the sun that are being depicted here. Now you'll notice that there's no date here for December 21st because the sun is below the horizon. Okay, it doesn't come out. North Pole is in 24 hours of darkness in the winter. It's in 24 hours of daylight on 6/21, or the summer solstice. So you'll see that the altitude of the sun is a little bit above the observer as it makes a circular pattern in a counterclockwise direction. So you'll see that there's 2 paths of the sun there. There's one right at the horizon, which is going to be basically your equinox, March 21st and also September 23rd. And the path that's a little bit above the observer, that's going to indicate that the sun never sets on June 21st, never sets. It's out for 24 hours out of the day. So that's it for now in terms of your sun's path. Very important for you to know your different latitudes. Definitely important for you to know the sun's position and the diagrams of what those latitudes are going to look like. I really outlined for what you would need to know in terms of New York. Okay, you definitely need to know what latitudes the zenith is going to be hit and the dates in which the zenith is going to be found at as well. Okay, so that's it for now. Good luck with your next exam, and we'll talk to you soon.